Hi, welcome back to the channel. In this video, we are going to discuss about a new problem in the singly linked list. Okay, so this problem is whether to check the list or the given list, whether it is palindrome or not. Okay, it's a very simple problem. So in the last video, we have checked how to do reverse the linked list using recursion and even using the iterative solution, right? In this one, we will be using the concept of the reversing the linked list, its application in solving this palindrome problem. So let's understand what is the problem and how are we going to solve it. Okay. So we are given this list, as you can see. Now we have to check whether this is a palindrome or not. Now, how do we check whether this is a palindrome or not? So basically, to check anything, whether it is string, object, list, or whatever integer, we just reverse it. And after reversing it, if we get the same list, okay. So after getting means reversing it, if we get the same, we say it is a palindrome. Now you might think we can just reverse it and we can check if this is a palindrome. Okay, but it's not that simple. Now the reason is in interviewer asks for much efficient solution. When we are going to reverse the whole linked list, we have seen that we take big of n and big of n space also for recursion, and when we go for iteration we take big of n time but big of 1 space. So even if we do by space or by taking this iterative solution, we are doing in n times. We need a more better solution. So the interviewer will ask to optimize that way, or to optimize that checking by checking the palindrome by reversing the list. So you have to present a solution which is more efficient than just reversing the whole linked list and checking the palindrome. Okay. So how to do that? So the solution to this problem is we reverse the linked list but not completely. We reverse from mid of the linked list. We reverse only the half of the linked list. Okay. So basically we are going to divide our linked list into two parts using the middle element of the linked list. Then check one by one. And we are going to match the character one by one of that to check whether this linked list is a palindrome or not. So basically what we are going to do, first we are going to find the mid of the linked list. So as you can see from here, this one is the mid of the linked list. So we will reverse it from here. Okay. So our original linked list will become this, and now 1 will not point to 0, rather than 0 will point to 1 and it will be pointed by 1, and that's all. Okay. Now what we are going to do, we are going to take a pointer current equal to head. Okay. And for this new list that we got by reversing, we get a new head here. This is a new head. Okay. So we will say this is a new head. Okay. So our current holds 1 and our new head, which are represented by NH, also holds 1. Right. So basically what we have to do is we have to traverse both lists and we have to see that whether current dot data equal to new head dot data. Okay. If any mismatch is there, we will return false. So basically within the loop only we will do if not equal to data, then then just return false. That's the very simple thing we have to do in the loop. Okay, so this is a very simple logic we have to apply. But before that, the problem is how to find the mid of a linked list. Now, if you traverse the whole linked list, then again it will be a big O of n time. So there is no point. We are trying to avoid the big O of n. We are trying to reduce that complexity, and that's why we are not reversing the whole linked list. Otherwise, we would do it iteratively. Okay. So how to find the mid of the linked list? Okay. So let's see. So there is an approach known as hare tortoise approach, or you can say slow fast pointer approach. What we do here is we take two pointers. One is slow. So I denote slow by S, and which initially points to head, and we take a fast pointer which I denote by F, which also points to head. Now, as the name suggests, slow moves one step at a time, and fast pointer moves two steps at a time. Okay, and whenever the fast pointer becomes null or its next become null, then we break out of the loop and we return the position of the slow pointer at that particular moment, right? At that particular condition, and that will be the mid of the linked list. So basically what we do is we do slow is equal to slow dot next, and for fast we do f equal to fast dot next, and our base condition we apply is fast not equal to null. So we check whether fast is not equal to null, as well as we check fast dot next is also not equal to null. We check this because we don't want null pointer exception. Okay, so that's a very genuine logic, that we do not want a null pointer exception, which is a very worst exception to see. Okay, now using this approach, how we reach the mid? So initially, as you can see, slow will be at 1, fast will be at 1, right? Now in the first iteration, first ITR, I say what is happening. So in first ITR we are at 1. As you can see, I am pointing here, highlighting it. Okay, so both are at 1. We check this whether f or fast is not equal to null. Yes, it is not equal to null. If fast dot next not equal to null, yes, it's correct. So we move slow to 0 and we move fast to 1. So slow dot next will be 1 dot next, which is 0, and fast dot next, which is 0, and 0 dot next is 1. So it reaches here. Now for second iteration, second ITR, we say S equal to, we check first condition. So condition is f not equal to null. No, it is f is not equal to null. We say f dot next not equal to null. So once next is not equal to null. So we are all set to go. So now slow becomes 1 and fast becomes 1. Now how it becomes? So slow will move one step at a time. So it will move from 0 to 1. So it reaches at this position. Fast will first move to 0 because f dot next, and then again dot next. So 0's next is 1. So it will reach next. Now we will check, is fast now equal to null? No, it is not equal to null. Is fast dot next not equal to null? No, fast dot next is now equal to null. So we will break out of the loop. And what we will say? We will say, wait. So if you can see here, I am returning slow. S. So we will just return slow, and slow is at 1, this one. Okay, all right. So this is, we have easily find the mid of the linked list. We have to pass this mid to our recursive function or any reverse function, and we will get the reverse linked list here, as you can see, which is I am highlighting here. Okay, so let's apply all this logic into our code. Let's code this basically. Okay, so we create a new function. So first, let's create a private function which will return the new head of the by finding the mid. Basically, not new head. It will return the mid node of the linked list. So find mid. So we will say find mid, and we will take a node parameter here. What we will do? Node equal to head. Okay, no. We'll take 2 pointer. Okay, we don't need to take any other pointer. So slow equal to head and fast equal to head. This is our initial condition. And always remember, we have taken static node head, and it is a global variable. Okay, static variables are global variables, so sort of in a class only. Okay, not outside of class. So slow is head and fast is head initially. Now we do while fast not equal to null, and then fast dot next not equal to null. What we have to do is slow equal to slow dot next, and fast equal to fast dot next, right? And whenever the condition is false, then we break out of the loop and we return slow. So finding the mid of the node is very easy, right? Now we will implement we will now code for our palindrome. Okay, so we will take a boolean. Boolean is palindrome. Okay, spelling is wrong, so palindrome. Okay, is palindrome. No parameters we have to take. We will just apply this function on our given list object. Okay, now what logic we have said? First, current node. So current node is head. Okay, as we have seen. So our current is head. So here we have seen also, we have to take current equal to head and a new head. Now from where this new head will come? We have to reverse it. So we will take a new head and we will call reverse recursive function. Okay, we will call this reverse recursive function and we will pass the mid. Okay, we will pass a mid variable. Now this mid variable comes from find mid function. Okay, and from here we are passing, our head. In fact, if you don't pass anything here, find mid, don't pass anything. We don't need anything basically. Okay, since head is global, so we don't need anything. Now what we will do is, next step is, now we got mid, we are passing mid to the reverse recursive function and we will get a new head. Now what we have to do, what we have discussed now, we have to iterate a loop and we have to check whether the current data mismatches or matches with the current new head's data. So it's as simple as that. So we'll say while current not equal to null, and then new head not equal to null. So this is our while condition. Till when we have, and what we have to do meanwhile, if current dot data not equal to new head dot data, then we return false. Okay, that's the simple logic we have to write. Else we will return true. Now there can be certain cases where, or corner cases, when we can't just return true, we have to check those cases. Okay, so there can be a case and we have to verify them, that if current equal to null and then new head also equal to head, sorry, null. Since both lists are complete and all the data is matched, so we will not enter this this condition. So means we are this is a palindrome, so we will return a true. Okay. One more condition can be, if current is not equal to null. Suppose current is not equal to null still, but new head becomes null. In this case, what we will do, we will check if current dot next is equal to null or not. If current dot next is equal to null, we are going to return true. This means that this is a odd list. So in the odd list, if you see here, what we have taken is a odd number of list. So here this is the mid. So from here it will start checking, it will come here, it will come here. So at this position, when the current reaches, we have to check this, right? If this is true or not. Else we have to return false. Okay, and similarly we just copy paste it again. Similarly we check for the new head. So if current by chance current becomes null but new head is still going on, then we have to check whether new head dot next is null or not, and if it is null, then it's fine, then it will return true, else we return false, right? So this is our logic for checking the palindrome. Now let's create a new list basically. So singly linked list, list 2 equal to new singly linked list. Okay, the way we have created here, we will be creating. So we will insert some element, list2 dot append. We will take the same list. Okay, this same list. 1. Let's copy it 4 times. So 1 time, 2 time, 3 time, and we copy it 4 times. So we make it 0 and we make it 0. Okay. Now let's check it. So let's apply, or we just say s out. First we print the list. Okay. List2 dot is palindrome, and this is for checking whether it is palindrome or not, but we will check the list whether we are getting it right or not. Okay. So let's first run the application, and it's coming false. Okay, the problem here is we have taken head as a static variable, right? So the property of a static variable is it is shared among all the objects. So if this this list is making any changes to the head, that will be reflected, that will be known by this list, because head is shared among both. So before we make a list, we have to make sure head is equal to null. Okay, we explicitly write head equal to null, and then we make a list, and then if we do it, we are getting it this. And I think we have entered into a infinite recursion. Okay, let's check what is the problem. Okay, so if not equal to null, not equal to null. Okay, so we have not incremented our current. Okay, sorry for this. Current dot next, and new head equal to new head dot next. This was a missing step, that's why it went into infinite loop. Okay, so let's run again. Okay, so it's giving true, so we are getting the good result. Let's check if, what if we change this to 2? Will it still give us the same? Yes, it is giving the same. Okay, I change it to 1 and I change it to 0. Let's see what it gives. It is giving false. It's obvious. Now let's check for odd or even number of cases. Okay, this is 1, 2, 3, 4, and 5. Okay, let's do this. List 2 dot append, and we take 1. So for even number of cases, it is giving correct answer, and if we change it here, then will it give false or not? Let's see. It's giving false. Okay, so for all cases we have seen, this code works. All the corner cases are covered, and we have successfully implemented this list palindrome case. Okay, and we have reduced our time complexity also, since we are reversing only this means we are not reversing in big O of n, we are reversing in n by 2. Also we are finding this, we are not traversing the whole list to find the mid, we are only traversing the half of the list, right? That's why the time complexity reduces very much. Okay, and this is the most efficient solution for checking whether the linked list is palindrome or not. Fine, so that's all for this video, and I will come up with some other interesting video in the next time. Till then, bye bye.